with, let's say, 3 levels of technologies, right? One is data acquisition, so connectivity is very important. And there we are talking about IoT with different protocols, okay? That's very important. Data processing for knowledge extraction from the data, I think is very important. So there we are talking about artificial intelligence or mathematical modeling in general, right? That's also very important. Then data visualization, graphical representation, I think is very important. So those are different layers we always work on, and they are relevant for the Industry 4.0. And then I think deployment in microservices, small microservices architectures are relevant, because there are so many building blocks going around in academic centers, research centers, universities, companies. They're all building in the European projects a lot of components which you can easily integrate together in one system through microservices. And I think that's a very relevant step forward. So leaving behind a little bit the big applications and going to microservices.
At the SIM 4.0 several years ago, we posed ourselves this question with the aim of being able to anticipate trends in the manufacturing sector and be ready both in terms of infrastructure and skills to meet our customers' demand. In this perspective, we invested in 2 main technologies, which are the essence of 2 pilot lines, namely artificial intelligence and additive manufacturing. Artificial intelligence has become an integral part of our daily lives, to the extent that many large Italian companies already extensively utilize it. The advantages of a business adept at leveraging this technology are now evident: workflow automation, the capability to execute tasks with a high degree of precision and consistency, enhanced user experience and customer satisfaction, streamlining of decision-making processes through data analysis, and significant time and cost savings. The novelty lies in the fact that this utilization is no longer exclusive to large enterprises, but extend to the remarkable opportunities presented by the new technological revolution, which also gathers the need of small and medium-sized enterprises in the industrial sector of not only Italy, but also Europe. Artificial intelligence in particular can truly represent the most effective tool available to companies to achieve the ambitious and necessary objectives of industry, not only 4.0, but also 5.0, reaching full social, environmental, and economic sustainability. However, it is necessary to take a step back and considering that there is no Industry 4.0 and therefore artificial intelligence without digitalization and digitization first. So what is digitization? It is the conversion of analog information and data to digital, while digitalization involves the broader use of digital technologies and tools. But even before digitizing the production processes, it's necessary to optimize them, so to detect and eliminate any waste and losses at the root. It is necessary to modernize outdated infrastructures and transition to current technological standards by adding new software, hardware, and protocols components. An important consideration concerns data, which are the true heart of artificial intelligence, assuming the value we can extract from them. Today, numerous companies have realized that they do not possess enough data to train artificial intelligent systems, and from an organizational and social perspective, training and skills are essential for all the stages of artificial intelligence life cycle, in particular data science, machine learning, and deep learning. Another enabling technologies in which we truly believe in is additive manufacturing, which unlike traditional manufacturing methods, which involving cutting away materials from a solid block, additive manufacturing builds objects layer by layer directly from digital design files. This approach offers several advantages, and it is expected to have a significant impact on manufacturing processes because it allows for the creation of complex geometries and designs that are difficult or impossible to achieve using traditional manufacturing methods. This design freedom also enables engineers to optimize production processes and performances, reducing weight and creating innovative new products. One of the most significant advantages of these technologies is the ability to quickly produce prototypes and iterate designs. Also, it enables mass customization by allowing each part of product to be tailored for the individual customer requirements, and has also the potential to disrupt the traditional supply chains by enabling decentralized production closer to the point of consumption. But most importantly, additive manufacturing has the potential to reduce the environmental impact of manufacturing using fewer materials, generating less waste, and consuming less energy compared to traditional manufacturing methods. Also, it has the ability to recycle and reuse materials that further enhances its sustainability credentials.